Hi there, it's Mrs. Tremblay. It is time for learning how to graph basic inequalities. You've been solving equations a lot, and in an equation there's an equal sign, right? Well, basically, inequalities are the same things as equations, except instead of an equal sign, they're going to have an inequality sign. And an inequality sign looks like these little symbols here. We have a less than, greater than, less than or equal to, and greater than or equal to. So as we get through this little section, you'll see that this is very, very similar to solving equations, but it's not exactly like solving an equation because inequalities can have more than one solution. And I'm not talking about the infinitely many that we were solving before with the special cases. It's just looking at it a little bit differently. Okay, so the set of all solutions to an inequality it's called a solution set. And basically this graph shows all the solutions of an inequality on a number line, because if we tried to list all of the solutions, we'd be doing it forever and ever and ever. Because as you can see on these lines, these arrows, those mean that the numbers continue going left and right forever and ever and ever. So we don't want to spend the rest of our life listing out all the answers, so we use a graph to express it. And the first thing I need you to know today is just how to graph a basic inequality. I mean, there's nothing really to solve. It's just understanding the direction of the graph and the open and closed circle and all that good stuff. So first off, if you see the symbol less than, you're going to use an open circle when you're creating your graph, because if something is less than an amount, it means it can't be that amount. It can only be less than that. So we're going to graph two examples here. It says x is less than -1, and basically it's pointing at the value that's lower. Our job is to graph all of the values that x can be. So we're graphing x. If x is less than -1, x can't be -1. So that's what I mean by this open circle. We're going to put an open circle at -1 to show that x can't be -1, but can't x be all the values lower than -1? And on this number line, all the values to the right are greater, all the values to the left are less. So we're going to graph to the left. So this right here shows that x is less than -1, and this arrow means we could keep going forever and ever. We're not going to, though. Nobody got time for that. What's kind of nice is if the variable is set up on the left, this will point you in the direction that you need to graph. It'll point you in the direction you need to shade. If it's not, then it won't. So this says that 0 is greater than x. That means that x is less than 0. So what I would recommend that you do, and trust me, I've been doing this for a while now, if you see the variable for an inequality is written on the right-hand side, just rewrite the statement with the variable on the left. It saves you a lot of hassle later. Meaning, here's x, here's 0. I'm still comparing those same two numbers. And in the original, you know how this little symbol's pointing at the x? When you rewrite it, make sure it's still pointing at the x and open to the 0. So these two things mean the same exact thing, except now that this is on the left, it's a little bit easier to read for graphing x. So if x is less than 0, can x be 0? No. So I'm going to use an open circle. X can be all the values less than 0. So we're going to shade those values in the line that are less than 0. All right, so that's less than. The next one is greater than. With greater than, it's going to be opened up at the x, and you're still going to use an open circle on that, because if x is greater than an amount, it can't be that amount. It can only be the amount greater than that. So this first one I have, x is greater than 1. I'm going to put an open circle on 1 because x can't be 1. But it can be all the values greater than 1, which means I'm going to shade to the right, because these are the values that are greater than 1. With this next one, this says -2 is less than x. And again, sometimes it's tough to kind of wrap your mind around what that means. That means that x is greater than -2. We're not graphing -2, we're graphing x. If x is greater than -2, so again, rewrite that. I didn't say it, but I did it. You should do it. X is greater than -2. It means it can't be -2, but it can be all the values greater than that. Okay, now I have the less than or equal to. So this has a little line underneath it. It means that it can be less than the value given, but it can also be that actual value. So when you plot the dot on the graph, you're going to use a closed circle because it can be that amount. For example, if x is less than or equal to 0, that means that it can be 0, And it can also be all the values lower than 0. So less than means shade to the left. This next one says -1 is greater than or equal to x. X is on the right, put it on the left. You're still comparing x and -1. In the original, it's pointing at the x. You want to make sure that when you rewrite it, it's still pointing at the x. You don't want to be changing anything. So if x is less than or equal to -1, I'm going to put a closed circle on -1. And if x is less, I'm going to shade to the left. Somebody said years ago that they just remembered to shade the circle in when there was a little line underneath the inequality symbol that meant you color it in. So it's like this little dash is filling up that circle. Whatever works. All right, the last symbol we're going to look at is greater than or equal to. So when greater than or equal to, it's opened up to the x. It wants to gobble up the x because it's worth more. And we're going to use a closed circle again. So if x is greater than or equal to 1, it means it can be 1. So I'm closing that circle. Or all the values greater, and greater means shade to the right. And with this one, this says -2 is less than or equal to x. Again, it's easier to understand if x is on the left. So I'm still comparing the x and the -2. And when I rewrite it, I want to make sure it stays open to the x just like it was in the original. So if -2 is less than or equal to x, that means that x is greater than or equal to -2. And that's what we want to graph. So x can be -2. And it can also be all the values greater than that. All right, let's try a couple on our, well, I guess you could pause and try a couple on your own. If not, you can keep going and do the examples with me. We're going to graph some of these, and they're all kind of mixed up now. So the first one I have y is, and it's pointing at the y, so that's less than or equal to 3. Zoom in a little bit here. All right, the first thing we're going to need is a little graph. And I didn't put numbers on here for you because I kind of want you to be able to do that for yourself. So the first step to kind of creating this, yes, you draw your little line. And if I'm comparing y to 3, I want my center value to be 3. And when you make a number line, if you could just give me one number on either side, that would be great. And it should be just in order. So if this is 3, that means that right before 3 would be 2, and right after 3 would be 4. So place this value here in the middle, and then put the appropriate numbers on either side. If y is less than or equal to 3, that means I have a closed circle on 3 because it can be equal to it, and I'm going to shade to the left because y is less. Next one, m is greater than -7, so I'm going to draw myself a little number line. In the center, I'm going to put a -7. I want values on either side. When you're looking at the number line, -6 is not to the left of -7. Remember, the greater the negative digit, the lower the value. So this should be a -8. This should be a -6. And does it really matter? Yeah, because when you shade it, if you have your number line backwards, you're going to end up shading the wrong values, which is not correct. So if m is greater than -7, m cannot be -7. So I'm going to use an open circle and shade to the right. Next one, ooh, a decimal. It's okay. Do it the same way. Draw your number line. In the center, I'm going to write 1.4. Now, you've got a couple options with this. You might not all choose the same amount. In the notes, I'm sure you will because we're doing this together. But if I was just going in order, I would probably stick with tenths and say 1.3, 1.5. If you put a 1 here and you had 1.4 here, then you'd need to put 1.8 there. As long as you are using equal increments, it's really okay. So if g is greater than or equal to 1.4, that means a closed circle. Because if it's greater than or equal to, it means it can be that. So close that up. Greater than means shade to the right. All right, with this next one, do you see how the variable is on the right? I do not like that. So rewrite this with it on the left. And right now it's pointing at P. So make sure when you rewrite it, it's still pointing at P. Now draw your line. And in the center, we have the value that's given. I have -2.5. And with this one, we can count by halves. That's fine. So if I was dealing with -2.5 in a number line, as I head to the left, if I go 0.5 this way, if I go a half this way, I'm going to end up at -3. And if I go in this direction, I would end up at -2. Because again, remember with negatives, it's kind of reversed. So the 3 is here, the 2 is there. And if p is less than or equal to negative 2.5, that means I have a closed circle because it can be equal to that, and it's less. If you just use this, you're going to have the tendency to say, oh, it's pointing me this way. But remember, that only works if the variable's on the left-hand side. All right, same thing with this next one. I want to rewrite this first. So I'm going to rewrite this where I'm still comparing b and negative 8. It's opened up at the opened up at the b, so I want to make sure it's still opened up at the b. Draw your line. Put your negative 8 in the center. And again, look up at the number line. Negative 9 is to the left of negative 8. Negative 7 is to the right. And if b is greater than negative 8, it means it can't be negative 8, so I'm going to use an open circle. And greater values are always shaded to the right. Okay, last one of these, and then we have a couple more on the next page. I have this reversed again, so I want to rewrite this, and I have m and negative 1/2. It's pointing at the m, so I want it to point at the m still when I rewrite it. I'm going to make my number line. In the center, I have negative 1/2. If you're on a number line, and usually when I see negative 1/2, it makes me want to count by a half. So if I go to the right, I would end up at 0. If I go to the left, I would end up at negative 1. So these are equal increments. And if m is less than negative 1/2, it can't be negative 1/2. That means it's an open circle. And I'm going to shade to the left because m is less, and left is less. All right, turn your page. Now what I'd like you to be able to do, we just graphed a given inequality statement. Now I want you to be able to write an inequality for each graph. Yes. And with this, I don't give you a set variable to use. You can use a variable of your choice. I wouldn't recommend using a t or an o or a lowercase l because those tend to look like numbers. I'll probably just use x for most of them, or maybe p. I'll use p because I use it a lot and then it makes me laugh, and I don't know if you think it's funny anymore or not. You're probably spent on that, but hey, sorry. Alright, so the easiest way to do this, after you choose a letter, write down the letter that you choose, and you're going to write down the value that's given on the graph as the point. So right here, there's a closed circle at negative 3, so I know I'm comparing my variable with negative 3. Now we have to decide what symbol to use, which is generally the trickier part. First off, see how that's closed? That means it's going to be an or equal to 1. So I'm going to draw a line underneath, because I know in all those statements, the ones that are equal to, the inequality sign has a little dash underneath it. Now if you're looking at this, aren't all the values greater shaded? Yeah. So that means that p is greater than or equal to negative 3, so it needs to open up to that. And remember earlier I said that this will always point you in the direction of the graph if the variable's on the left? Yeah, this points you that way, and that's the way that it's shaded. All right, let's try another one. All right, again, I'm going to write down my variable. There's a closed circle on the 1, so I'm going to put 1 on the other side. I see that it's closed, so I'll put a line underneath. And all these values are shaded in this direction to the left, so I'm going to use a less than for left. So this represents p is less than or equal to 1. Next one, I'm going to write down my variable, write down the amount that's given with a circle. This time it's an open circle, but it's still a negative 2. And if you look at this is shaded to the right. That means that p is greater than. I'm not going to put a line underneath that because it's not a closed circle. So p can only be greater than negative 2. It can't be negative 2. And the last one of these, I'm still going to choose my variable p. Why not? And this is an open circle on 2. So I know I'm comparing p with 2. P isn't number 2. I should have chosen 1, shouldn't I? Anyway, if p is less than 2, then that looks like that. So basically, the inequality symbol can point you in whatever direction the line is going as long as your variable's on the left. Not too bad. Okay, last part, best for last, the math story time. Basically, I want you to be able to now take a verbal statement and put it into an actual inequality symbolic type statement. So we are going to write the inequality, then we're going to do a graph of it. It's kind of putting everything together. I hope to earn at least $250 this summer. Yep, that's what I'm hoping for. Okay, so what I want to do is I want to write an inequality for the amount of money I hope to earn. So I'm just going to call that M for money. So we just chose a variable, right? And I see the amount that's given is $250, right? Now it says that I hope to earn at least $250, right? So would I be happy if I earned $250 if I said at least $250? Yeah, so that means it can be equal to $250. I'm going to draw a line underneath it. And that's a nice first step to think about. Can it be the amount that's given, or does it have to be more or less? So think about this. If I hope to earn at least $250, would I be happy if I earned $200? No, I want to earn at least $250. Doesn't that mean $250 or more? So the amount of money I want to earn needs to be greater than or equal to $250. I'm going to draw my line. I'm going to put 250 in the center. And if you wanted to, you could count by 50, and you could make 200 here and 300 here. You could count by ones. You could count by fives. I'll count by 50 this time. Why not? As long as you are using equal increments, I'm okay with whatever you count by. Your center value, though, should be whatever the amount's being compared to, whatever the variable is being compared to. So if m is greater than or equal to 250, that means a closed circle, and I need to shade to the right. And this should make sense, right? You'd be happy if you earned 300 if you wanted to make at least 250. So you can do kind of a double check at the end to make sure your answer makes sense. All right, the next one says, to receive credit for T2R, you can have no more than 6 zaps. Okay, so we're going to call this C for credit for T2R. And I see that it's being compared to 6. Okay, this says no more than 6 zaps. So you can't have more than 6 zaps, but can you have 6 zaps? Yep. So that means it can be equal to that. And if you can have no more than 6 zaps, right, you can't have more than 6, so you must have less than that. So to get credit for T2R, you could have 6 zaps or less. So C is less than or equal to 6. Draw your line. I'm going to put my 6 in the center. This time I'll count by ones. And because it's less than or equal to, it's closed. And we're going to shade to the left because you can only have less. So you can have 6 or less. That's what that means. Okay, almost there. I need to earn more than $100 to pay my bill. So I need to earn more than $100. So I'm going to use E for what I want to earn, and it's being compared to 100. Now, if it says more than 100, can it be 100? No, I want to earn more than 100. So that means the amount of money I earn needs to be greater than 100. This time it's not equal to. So I'm going to put 100 in the center. And this time, why not? We'll count by tens. How about that? So on the number line, if I was counting by tens, the lower one would be to the left, the higher one would be to the right. If the amount of money I earn is greater than 100, it can't be 100, but it can be all the values greater. Last but not least, and this is kind of very, very similar to letter B, but you'll see how it's different in a sense as well. Students that receive more than 6 zaps in a quarter will not receive credit. So students that receive more than 6 zaps will not receive credit. So I'm going to call this, let's see, how about Z for zaps? Why not? Doesn't really matter what letter you choose. And I see that I'm comparing that to 6. This time we're going to graph the students that don't get credit for T2R, because it says students that receive more than 6 zaps won't get credit. So we're zapping the people that won't get credit. And it says if you get more than 6. So can you get 6? Yeah, you just can't get more than 6. So if your zaps are greater than 6, that means you're not going to get credit, and that's what we're graphing, people that won't get credit. So we're going to put a 6 here. I'll just count by ones again. And if Z is greater than 6, it means it can't be 6, because you can still get credit if you have 6. But the second you get one more than that, you're done. No credit. All right, we're done. Hopefully that wasn't too painful. See you later.